Hi Nitin, you're the host and it's streaming live.
Okay, sir. Thank you. Okay. Good evening. We'll start off. Okay. Today we are supposed to read about magnetism. Just we are just brushing up the formulas, then we can go up to. We can directly go to solving questions. Okay. Okay. So the first thing is we are talking about Biot-Savart's law, which says that to find out the magnetic field due to a current carrying conductor, you have a current carrying conductor this through which I current is going. So we are taking an element dl where the theta between the point where you're trying to calculate the electric field and the magnetic wire, it is theta. For this, dB value will be equal to mu naught upon 4 pi ideal sine theta r square. Because ideal sine theta, we can remove it because sine theta is used for cross vector. So ideal magnetic field due to a straight current carrying wire. So straight carrying wire, we can find out the magnetic field using this formula where B is equal to the B is magnetic field. Magnetic field is equal to mu naught I upon 4 pi r cos theta 1 cos theta 2, where theta 1 and theta 2 are this angle. Or I can write it in terms of sine, where sine alpha plus sine beta, this angle. Okay, this is the point where we are trying to calculate the magnetic field. Okay. So this is first thing of Biot-Savart's law. Then this is what we are reading about circular loop. At the center of the circular loop, how you find out? So at the center of circular loop, you find out the magnetic field comes as mu naught I upon 2r, which is outward in the direction. Okay, on the axis of loop, we find out using this formula, which is mu naught 4 pi 2m r square plus x square, where you can see r is what, x is what, m is what here is. M is basically your magnetic moment. Capital M is nothing but it's magnetic moment. Now, when I'm talking about magnetic moments, what we have studied in the case of dipole electric electric dipole, same thing, you have magnetic moment over here, and the magnetic moment formula is basically given as by the distance between whatever distance is there, and then what will be the say magnet strength. Okay, based on that, we try to calculate this. Next is Ampere Circuit Law. It states that the line integral of a magnetic field over a closed path is equal to mu naught the times of algebraic sum of the current threading the closed part in free space. Okay, so it's basically, if you remember what we have studied in the Gauss law, we used to study it as what? We used to say that 1 by epsilon naught times by the charge enclosed, or whatever charge is present in that particular thing. But here it's only ulta of this, it's mu naught times the algebraic sum of the current threading it. So instead of 1 by epsilon naught, it is only mu naught will come there and everything stays same. There we used to write this is equal to electric field into area. Here we write it as magnetic field into the length. So that's what is Ampere Circuit Law, where we say it as B dl, or you write it as B dot dl, or you can write it as B dl cos theta, which will be equal to mu naught I, whatever is being enclosed by that, or what will be the charge present in that particular system. Okay. So Ampere Circuit Law is written like this, and this is what we say implies the integration of scalar product around the closed loop, which is known as Amperian loop. The current I enclosed is the net current encircled by the total loop, how much current is totally flowing in this. Okay, so this is how we write it at. Okay. Next, we have some examples where we are using Ampere Circuit Law to find out the magnetic formula wise. This is magnetic field because of a long thin current carrying wire, and then magnetic field inside a long straight current carrying conductor. For this is a formula. For this is a formula where you can see that they have written as the magnetic field inside is directly proportional to R. That means if you are increasing magnetic field, this R also increases, R increases magnetic, so they have a straight line nature. So this is what here shown as this is the top view. For this particular situation, they are giving a top view for this. You can see that inside is R, outside is capital R, and then they have taken a small length df, and the magnetic field inside that is B. So that B is given as mu naught IR, mu naught IR, where R is the inner radius, and then upon 2 pi capital R square, where capital R is the bigger radius or the outside radius. Next, formula for solenoid. Solenoid is nothing but this is what is solenoid. Okay, it's basically a helical form cubed, where we talk about that if you have turns per unit length is n, and it's carrying a current I, and the magnetic field B is given as point P, which is in the middle, is mu naught Ni. And when I'm talking about at end, any end, it will be mu naught Ni by 2, where I is current and N is the number of turns per unit length. Force on a moving charge in a magnetic field is given by QVB sine theta, or you write it as cross product of V, where Q is the charge, V is the velocity, and B is the magnetic field. Also, F is perpendicular to both velocity and magnetic field. Okay. This things is what you have to know. Like, yeah, for this, what is the formula? Formula based, a lot of questions will come. So yeah. Next, force between the two current carrying charges. Okay, so if the current is there in the same direction, you'll have an attraction. When there will be a current which is going in opposite direction, so that is repulsion. What will be the magnitude for that? It will be written as mu naught I1 I2 upon 2 pi R, where R is the distance between the two current carrying wires or conductor. It can be anything. It can be conductor. It can be a wire as well. All things can be counted in that. Okay. Next, when I'm talking about force on the segment of length L, if I have to find out at some particular point, if at a segment, I take a segment here inside this L, so that time we just multiply it with L, the formula. So the force on a segment of any particular segment inside this wire somewhere, like say I'm trying to find out whatever the magnetic field here, where, so this is L, so that distance. So at this particular segment, what will be the magnetic force? is given by mu naught I1 I2 upon 2 pi r into L. This is L. Okay, conversion of into ammeter. A small resistance which is called a shunt is connected into parallel with galvanometers. Okay, so when I'm trying to convert something like galvanometer, basically conversion, which the conversion of galvanometer I'm doing. Galvanometer is nothing which is, galvanometer is again one some instrument or some device which is used to measure current itself, but this is what, this is very sensitive. Sensitive in the sense, what it means is, sensitive means it can even it will show deflection for a very small amount of current also. So to convert galvanometer in form of ammeter, what we do, we take a shunt resistance S which is connected in parallel with galvanometer. So you can see I have a shunt resistance connected in parallel with the galvanometer. So Ig is the full scale deflection of the current, or you say that Ig is the current which is going through the galvanometer. So for this, what we write it as, this is what we write basically, IR is equal to IR. Okay, so IR is whatever the IR value which is going in this will be equal to whatever is going into the shunt resistance. So for this, we find out the value for shunt resistance is equal to this much. Okay, this is what I'm trying to convert ammeter in galvanometer into ammeter. What we are supposed to know is, for convert galvanometer into ammeter, we try to connect shunt S is connected in parallel. Next, to convert the gas, again galvanometer only are trying to convert it into a meter. For this, to convert it into a voltmeter, what we do, we take in high resistance. There, what we were doing, small resistance. In case of, I'm trying to convert into ammeter, I'm trying to take a small resistance R which is connected in parallel. Here, high resistance is connected in series. Okay, so that's what we are doing here. Here also same relation, Ig plus R. So for this is what I'm getting the relation. R is equal to this much, V by Ig minus G, where I is the current in galvanometer and G is the resistance of galvanometer. Few points: an ideal ammeter has a zero resistance, an ideal voltmeter have infinite resistance, an ammeter is connected in series in an electric field, and voltmeter is connected parallel across the device whose potential difference to be measured. So this is very common things. Okay, and we know that ammeter runs on small resistance, voltmeter runs on higher resistance. Okay, this is few formulas related to Earth magnetic field. Okay, so this Earth magnetic field, where delta is the angle of declination and phi is angle of dip. The horizontal component of the Earth's magnetic field, that is BH, is B cos phi. The vertical component is B sine phi. BH plus BB will give you the net magnetic field of Earth. Okay. Tan phi, the direction will be given by vertical component of an horizontal component. Tan phi 1, we want to find out tan phi 1. Tan phi will be the apparent angle of dip is find out by tan phi by cos theta. Or you write it as vertical component BH cos theta 1. Important formulas. Okay, coming to the further thing where we talk about electromagnetic induction. Magnetic flux is related basically to Faraday's law. So what we write, magnetic flux is equal to B dot A or BA cos theta, where in electric field, if you remember, electric flux is written as electric field into area. Here it is magnetic field into area. Unit is Weber, SI unit. Maxwell is CGS unit, and 1 Maxwell is equal to 10 raised to minus 8 Weber. Okay. Faraday's law of electromagnetic induction says was, the first law says is, an EMF is induced in a loop when the number of magnetic lines, that is magnetic flux passing through the loop, is changing. If the loop, the magnetic field of lines which is crossing that is changing again and again, because for that what we'll get the EMF induced. And also when we're trying to find out the magnitude of what EMF is being introduced here, EMF E induced in conducting loop will be equal to the rate at which the magnetic flux through that loop changes with time. Okay, so E is basically what is it, EMF, which will be equal to d phi b by dt, where I'm talking about phi b is magnetic flux. So okay, so this is rate because we are trying to find out the rate of magnetic flux. That's why we are writing it as d phi by dt. if I like this n is what? N is basically number of turns, n turns. So we just write n here and d phi by dt. And negative sign here implies that it is opposing the flow, and that is what we are trying to explain it through the Lenz's law. Lenz's law is was the flux of a magnetic field due to induced current opposes the change in flux that causes the induced current. So the previous thing which we wrote in previous thing we were trying to oppose it. So that's why we wrote it as that, yeah, the induced current it will be proportional to that. Next, when I'm talking about induction, we have two kind of induction. One is mutual induction and second one is self induction. So mutual induction is property of two coils by virtue of which each opposes any change in the magnitude of current flowing through the other by inducing an EMF in itself, provided magnetic flux on one coil is linked with other. So the thing is, now say what we are saying, that I1 is a current flowing through one coil and phi2 is the flux linked with the other one. Why? Because magnitude of any, it opposes what? Each opposes any change in the magnitude of current flowing. So magnitude of current flowing is current we took, and for which what it happens, you have induced EMF in the other one. So induced EMF of one. So one, if I'm taking current, other has to be from phi. So for one I took current, so the second one I took phi. If I would have taken here phi one, so here I would have taken current. Okay, so I can say that phi two is proportional to I1, which is written as phi two is equal to MI1, where M is the term which represents mutual induction. Induced EMF, we just read the formula, is minus d phi by dt. For 2, I'll write it as d phi by dt. If I have to include number of turns, I'll just multiply this by n, number of turns. So I write E is equal to minus di1 by dt. We're just writing the formula because we know that phi is equal to mi1. Here we wrote that phi 2 is equal to mi1. So because m being constant, it will come out. So if I'm trying to find out d phi t with respect to time, m will being a constant, it will come out and I get it as di1 by dt. Important cases, mutual inductance of two solenoids will be equal to this thing, where n1 is the number of turns in one solenoid, n2 in another solenoid, area of cross section of narrower solenoid, whichever will be narrower, that area of cross section you have to take, and L is the length of solenoid. We are doing all the questions at the last. Okay, so I'm just brushing up the theory. Self-induction is property of a coil by which it opposes any change in the magnitude of current flowing through it by inducing an EMF in itself. It is now going to have, so it is opposing change in magnitude of current flowing through it by inducing an EMF in itself. So phi is equal to Li, E is equal to minus L di by dt, where L is the coefficient of self-induction. Both M and L have a unit Henry, SI unit, which is equal to 1 joule per ampere square. Both have the same unit because obviously both are inductions, so inductions unit will not be same, not be different. Few formulas where we talk about energy in conductor. Energy in conductor formula is given by this: half L square, Li square. L is what? Your self-induction. I is current flowing through it. Energy density can be given as B square by mu naught. Combination of inductors. If inductors are in series, we write it as L1 plus L2. If I have some mutual induction in that, we write it as L1 plus L2 plus or minus 2M. Okay. If I'm considering the in parallel, I write it as 1 by L, 1 upon N1 plus L2. If I have to find out the relation between self-conductance and mutual conduction, we write it as M is equal to K root over L1, L2, where L1 and L2 are what? L1 and L2 are coefficient of couple. L1 and L2 you can say is what? Is self-induction, M is mutual induction. Okay. Fine. Eddy current, when the magnetic flux through a large piece of conducting material changes, it induced currents appear in the material. This is the thing which we talk about. The examples are magnetic brakes. What is happening is when you have magnetic flux through a large piece of conducting material, if it is keeps on changing, it will induce a current. I'm just coming old type. I'm changing the current, magnetic flux was being introduced. If I'm changing magnetic flux also continuously, current will get induced, and this kind of currents are known as eddy currents. Magnitude of eddy current is given by epsilon by R, where E is what? EMF, EMF d phi by dt by R, where R is the resistance of conductor. The direction of eddy current is given by Lenz's law or Fleming's right hand rule. What is the uses of it? It can be used as induction for this. Magnetic brakes, when we talk about trains and all, that is magnetic brakes. Speedometers to measure speed. Damping in galvanometer. Deadbeat galvanometer. Okay, next is transformer. Transformer is a device which is used for converting high voltage into low voltage and vice versa without changing the power. We have two kinds of transformer. One is step-up transformer, which is basically it converts low voltage into high voltage. Then we have step down, which converts high voltage. Down means it will convert voltage high to low. Up means it will take low voltage to high voltage. The principle of transformer is based on mutual induction, and transformer always works on AC. The input is applied across primary terminals and output is obtained across secondary terminals. Okay, or you say it as primary coil, secondary coil. The ratio of number of turns in secondary and primary is known as turn ratio. So secondary upon primary is known as turn ratio. If EP and ES are the alternating voltage and IP and IS are the alternating currents across primary and secondary terminals respectively, then for an ideal transformer, we write secondary. This you can say they are inversely proportional here. E is inversely proportional to current here. You can see ES, IS, and it is directly proportional to number of turn. Okay, it is directly proportional to number of turn. So E is inversely proportional to current. So because we have to maintain the ratio, right? So basically to maintain, we should not cross the value total multiplication of E and I will stay constant. So to do that, if one is increasing, other one will be decreasing. That's why we write that one is highest or they are inversely proportional. And efficiency of the practical transformer, it is P output by P input, which is ESIS upon EPIP, which will be less than 1, because for a practical transformer it is less than 1. For an ideal it will be equal to 1, 100% efficiency. Okay, so now this thing, average value formula or RMS value for AC. Mean or average value of AC is given by 1 by T root over integration from 0 to T EDT, or I mean is same, I instead of E, I will come. We have different values for this. We'll take it in the next slide. RMS value of current is what? It is equal to the value of DC, which when passed through a resistance for a given time will produce same amount of heat as produced by an AC when passed through the same resistance for same time. RMS value are also known as virtual or effective value, or this is the value which we get in our home. Okay, this is basically that value which is supplied to our home. Okay, so when I'm talking about average value for different things, we have different, if I'm different limit, we get different answer. So when we're talking about, see, E square RMS is given like this. If I'm talking about I mean from 0 to T, 0 to T means what? This is for one cycle. So for one cycle, if I'm trying to find out average value, it will be equal to 0. I mean, if I'm trying to find it for half cycle, it will be equal to 2 I naught by pi. I RMS is equal to I naught by T, where I naught by root T, where T is equal to T. So you have to remember this. You can see IRMS is not changing if the time period is half fulfilled. Only thing what changes is I mean will become 0 for one cycle, and for half cycle it is 2 I naught by pi, which is something around 0.687. The value comes something around 0.687. So similarly, everything is written for this thing. I mean will be I naught by pi if T is equal to T. So what is important for you is the first one. You can see this formulas where we are solving the questions. You can come across with all this formula. Okay, we have different kind of AC circuit. It can be either purely resistive, that means it will only contain resistance, or it can be purely inductive, or it can be purely capacitive. Purely inductive basically means what? It can only conduct, it can have only an inductor. Capacitive means it will only have a conductor. So now in a resistive circuit, the I is given as I naught sine omega t. So E I naught is equal to I naught is what? It is highest value or peak value. Okay, so same thing, I naught is also peak value. So here you can see that here you don't have any lag. It is I is equal to I naught sine omega t. Okay. Now, but when I'm talking about inductive effect, I, or we write it as like, because we have minus pi by 2 in case of inductor, the voltage lags by the current lags by pi by 2 when it is compared to voltage. In case of capacitive circuit, the voltage or the current is actually ahead by angle of pi by 2 phase. This is phase when it is compared to what? Voltage. We will see the circuits also. What this is what is important. I naught here is calculated by E naught XL, where XL value is omega L, or you can write it as omega can also be written as 2 pi F, so 2 pi FL. Same of capacitive circuit, X naught XC, where XC is written as 1 by omega C, where omega is equal to 2 pi nu C. Just substitute a value of omega. Okay, next is series NCR circuit. It contains all the things which is inductor, capacitor, and resistance. In series, it is connected. We have different phase relationship. When VL is greater than VC, that is, if it is an inductor, which have only inductor is dominative, that time it is the V will lead I by 5. Okay, the voltage is going to lead I by 5. Tan phi value is written, and in this case, XL will be greater than XC. Case 2, when VL can be less than VC, that time V lags I by 5. Okay. In both the cases, to find out voltage, we have the formula is V of resistance square plus VL minus VC whole square, where VL is the voltage in the inductor, VC is the voltage in conductor, in capacitive circuit. So we can write this as this formula also, where R square XL minus X is known as impedance. Okay. Power factor is equal to cos phi is equal to R upon Z, where Z is impedance. I will take this formula and put it here. Okay. Same thing again, there are few points where we can have the situations. Okay, in series LCR circuit, where this is what is known as quality factor. Quality factor is given by, here the formula I think is not visible. The quality factor is basically written as 1 by R upon L by C. 1 by R upon L by C. Okay. And this is case of resonance circuit. Okay. Next is series LR circuit. Formula for this is written here. You can see as Z is equal to R square plus XL square. We don't have any capacitance here, so we are not including capacitance over here. In case when it is CR circuit, only capacitance and resistance are there. You don't have inductor in that. For that case, the formula will become VR square plus VC square, because VL square term will become 0. So that's why the impedance also will become R square XC square. I will be equal to V by Z. Cos phi is written like this. Okay, so voltage is lagging behind. Or we have series LC circuit here, there is no resistance. So that time I have only inductor and capacitor, then what will be the situation? Okay. Next, this is important for you. What is power consumed? Power average is equal to 1 by 2, 0 to t. Okay, E there is E naught sine omega t, and I is equal to I naught sine omega t 5. P average will be written as E naught I naught by 2, because we are writing basically E naught is basically E RMS. Okay, E naught is basically E RMS. So we write it as E RMS by root 2. ERMS is equal to E2 root E. Okay, so we are just substituting here. This is with EV value, you say EV value or ERMS value, both is same thing. Okay, this is important. Okay, there is few points. So for pure resistor, phi is equal to 0. So P average will be equal to this much. For pure inductor or capacitor, P average is equal to 0. Power consumed is independent of IV sin phi. This is known as wattless component. Okay, IV phi, sin phi. Cos phi is power factor, which is equal to R upon Z. In a series LCR circuit, P average, that is power average, is equal to EV IV cos phi. EV square by Z cos phi will be equal to IV square R. This is in current in your current voltage. IV sin phi is wattless current. At resonance, that is omega R will be equal to 1 as because when we talk about as resonant, at resonance, what happens? Omega, if you have two conditions, we write it as what? XL will become equal to XC. So XL value is what? It is omega L, and XC is omega C. So when I write this, I get it as omega square is equal to 1 by LC. So when you simplify this, you get it as basically 1 by root over LC. So this is the case when it is in the resonance condition. So in resonance condition only we get all these cases. This is the case in resonance. So using this, we are writing this is what is omega R is basically it represents the resonating frequency, which is 1 upon root under LC. In this case, if Z is equal to R, this is power is maximum over here. At frequency other than omega R by LC, power consumed is less. In case of resonance, the power consumption is most. Okay. Further, at omega 1, omega t, you have different values for I max. We'll see it when we are doing the questions. I max utilizations. Okay. So this is what is a theory. This is very small theory session. I know most of you will be focusing on questions at present. We'll start off with the questions. We have a set of questions. So we'll start with the question 1. Everyone can start solving this. Okay. These questions are based on whatever formula we have done now, or if you remember this is just for a brush over. You can do the question. Through the questions, you can revise the concepts as well. So please start off. Start off with the questions. Let's see the question. What is given here is Q is given as 1 microcoulomb. So I have Q value which is equal to 1 microcoulomb. Or I write it, and if I want to write it in SI unit, I'll write it as 10 raised to minus 6 coulomb. Then I have a velocity given which is 2I plus 3J plus 4K. It is already meter per second, it's an SI unit, so we don't have to change it. And then we have an external magnetic field which is given as 5I plus 3J minus 6K into 10 raised to minus 3 Tesla. So again, this is an SI unit. They're asking you to find out what will be the force on, if you have to find out the vector of the force. Okay, so vector of the force, also the formula what we have here is the Lorentz force, which we use it as F vector will be equal to product Q into product of velocity vector into B vector. So it's V cross B. I know the value here. This will be 10 raised to minus 6. And because I have 10 raised to minus 3 for B, so I'll write that also outside. 10 raised to minus 3. For using cost product, what we can do is we can use this IJK where we have two vectors given us. So vector is equal to 2, 3, 4 is there. And the other vector here is 5, 3 and -6. So let's solve this thing. How much it will be? Basically, it will become 10 raised to -9 over here. And this will become how much? 3i. So if you take this, so you cover this one. This is basically we're trying to find out a will be 3 minus 6 minus 18 and minus 12. So it becomes minus 30i. Then if I'm taking j, so it will be 2 minus 6, 12. 12 minus 5 and 4 minus 20. So minus 32. So it becomes plus 32 j, because the center we write it as, I hope you know expansion of this. And then further I get it as k block. So 2, 3, 6. 6 minus 15. 6 minus 15 is minus 9k. Okay, so you can see here that I am getting the force vector. Force vector is written as F vector can be written as minus 30i plus 32j minus 9k. That can be a minus 30i, 30jk. Yeah. So the vector here is this. Magnitude is 10 raised to -9. Again, will be added in. But they are not asking the magnitude. They have written C here. They have given you it in this format, right? So I got already 10 raised to -10. With that, whatever I'm getting is basically what is F vector. So F vector is this one. Let's go to the next question. Okay. Next is this try proton atom kinetic energy 1 megaton. Okay, we'll see the question says what? We have a proton with a kinetic energy of 1 mega electron which moves from south to north. So south to north it is moving. So here this is north, and it gets an acceleration of 10 raised to 12 meter per second square by an applied electric field. That electric field is moving from west to east. So this is magnetic field is moving like this, and then proton have a kinetic energy in this direction. The kinetic energy is having, so kinetic energy in this direction, that means basically velocity is in this direction, acceleration in this direction, and acceleration is given as 10 raised to 12 meter per second square. You have to find out the value of magnetic field. Okay. Fine. So now we have what is, as we know, according to the equation, what is that force is equal to QVB sine theta. Either you write it as, if you write it in this fashion also, I can remove it and then write it in the magnitude form, so it will become QVB sine theta. As we have written here, you can see the angle between V and B is 90 degrees. So sine 90 degrees is 1. So I can write it is equal to QVB. Also, force can be written as mass into acceleration. Force can be written as mass into acceleration. So you can write that it is mass into acceleration. Okay, so force is equal to mass into acceleration. So I think all the values is known to us. We have to just substitute it. Right, all the values are known already. We have to just substitute it to get the answer. There's no unknown in this. So we have to find out acceleration. Acceleration is equal to QVB upon M. Now Q value is given to you. Okay, you don't need Q value. You know that Q value can be written in the form of, I know that it is basically a proton. So I can write that. Again, I can substitute in place of V, because kinetic energy is given to you. I can write, if you remember, the P is equal to mv, or I can write kinetic energy formula is basically equal to half mv square. From here, if I want to find out kinetic energy, from this, if I want to find out the velocity formula will be nothing but V will be equal to 2 kinetic energy. So I can write this in the form of 2 kinetic energy upon m under root. So I'll substitute that here. So it can be written as what? Q. In place of Q, charge of electron, I can write it as E. So E B by M, root over I have what? 2 kinetic energy, right? So I'll write it as 2 km, 2 kinetic energy. So in place of kinetic energy, we'll just substitute our value. So kinetic energy value is equal to, I have kinetic energy value. Can we just write it as 2 kinetic energy by M? And when I'm trying to solve this, after substituting all the values, I'll get here B value as equal to 1 by root 2 into 10 raised to minus 3 Tesla, which is approximately equal to 0.71 MT. 0.71 MT. The acceleration value, everything is known to us. Acceleration value is given to you, kinetic energy value is given to you, the rest mass of the proton is given to you. So mass is given, charge, we know a charge is equal to how much? 1. E value will become how much? 1.6 into 10 raised to minus 19. After substituting everything, you get this answer. Next, try. Let's see the question. A particle having same charge as of electron moves in a circular path of radius point. Okay, so radius of the circular path is 0.5 centimeter. Under the influence of a magnetic field of 0.5 Tesla, this is 0.5 Tesla, an electric field of 100 volts per meter, thus makes it to move in a straight path, and the mass of the particle given by this will be how much? Okay. So because if it will be moving in a circular path, the centripetal force will be equal to the QVB sine theta. So we'll find, because the path is straight line, so because of that thing, what we get it as, this is equal to QVB. Okay. Now, because I can write this as what is, it can also be written it as, let's say this is QVB sine theta, is this velocity gets cancelled. So I'll get basically what? MV is equal to M velocity and mass is equal to QBR. This is one equation I'm getting. Also, in terms of kinetic energy, if I'm trying to write down, the force is given as Q into electric field, F is equal to QE to provide this force, which is equal to QVB. Okay. So here in this, if I try to see, if you can see here, Q and Q gets cancelled. So I can write that velocity from here is equal to, yeah, so velocity from here also we can write down. So velocity from here is equal to basically E by B. So from here velocity, if I'm just trying to segregate the velocity value, so velocity value will be equal to QVBR by M. So this becomes second equation, because both is the equation for velocity, we can equate this. So if I'm equating this, I'll get it as what? E by B will be equal to QBR upon M. I need to find out what? I need to find out the mass of the particle. So M is equal to QBR. M is equal to QB square R upon E. Now Q value will be equal to how much? 1.6 into 10 raised to minus 19 coulomb. B is given as a Tesla, so 0.5 into 0.5 SI unit. R is radius, it is in centimeters, so it will be converted into meter by multiplying it to 10 raised to minus 2. Electric field is volt per meter, so it's in SI unit. So this is 100. Okay. So to solve this, 16.625, 1.6 and 100 up, so 21, 23, right? So it will be, this is what you're getting it as answer, 2 into 10 raised to minus 24 kg. Okay, so this is basically when the particle is moving in a circular motion, and F is equal to QE, the force in when an electric field E is applied on a charge Q, the force produced is equal to QE. So if you equate to this thing, you can find out the equation. I could not do it for anything else. I just equated velocity because velocity is the only term which is common in both of them, and we can use that because of that. There's no other reason that why I've just found out the equation in terms of V, because V is the term which is common in both of them, so we can use that. Okay. Let's try the next one. Okay, next is a proton, an electron, and a helium nucleus have the same energy. They are in circular orbits in the plane due to the magnetic field perpendicular to the plane. Let RP, this is RE, this is RP, RE, and RHE be their respective radii, then what is true? Okay, we'll see the solution. Proton and electron in the helium nucleus have the same energy. They are in a circular orbit in a plane due to magnetic field perpendicular to the plane. Okay, perpendicular to the plane, that means sine theta is 90 degree, so on. So basically what I can say, same thing, if it is moving in a circular orbit, mv square r, that is centripetal force, will be equal to qvb sine theta sine 90 is 1, so qvb, v and v1 gets cancelled. So I can write that r is equal to mv by qv. I can write this. Now, because this is given to, also I can write it as what is, in place of mv, just now we saw that we can write it as 2m kinetic energy. 2m kinetic energy. 2m kinetic energy upon qb. Half mv square we are using, half mv square. So v will be m into v will be how much? You can see that if you want, kinetic energy is equal to half mv square. So if I'm trying to find out v value will be equal to what? V square will be equal to 2k by m, right? So I have to find out mv value. So mv value, basically what I do, what is multiply both sides by m. This is also as this also as m. So I'll get it as mv square is equal to m square v square is equal to root under 2 mke. If I multiplied m by both sides, if this is root, if I'm taking the squares out, if I'm not, I'm getting this formula you have written in the forms of p square, that is momentum square. If this is what is m square v square, if I'm finding out mv, that is momentum will be equal to root m k. So I substituted that. Okay. Now after substituting this, now if I'm writing it for alpha particle, beta particle, I know that mass of helium, because helium is written as what, 2 and 4. So if I'm talking about mass of helium, it is 4 times of mass of proton, because mass is 1 for mass and proton. Okay. And also if I'm trying to write down to the charge on the helium will be basically 2 times whatever charge q have, or a proton or electron have. Normally the charge on proton and electron both are same, which is in the terms of 1.6 into 10 raised to power minus. So I can see here from this, what I can say, that mass of helium is, from this point I can say what is mass of helium is 2 greater than mass of proton. And this is another equation here which I have. So if I'm trying to interrelate the things from here, what I can write, that R is directly proportional to root over m. If I'm taking that kinetic energy is same, because they mentioned that they have the same energy. So from this equation, if I want to write kinetic energy is same, 2 is a constant, and so it is proportional to root over m upon q. So this is 2 things which we have to see. So I'll say the mass. So I can write that here. You can see the mass of proton is 2, or mass of helium is 2 greater than whatever we are talking about proton. So this is one relation. This is second relation. Also we know that mass of proton is quite big when we compare it to electron. It is 1 by 1837. That much is the, so it is basically the mass of proton is equal to 1837 times of mass of electron. Okay, so this, using this 4 equation, if I want to substitute things over here, what I can write it individually, if I want to write it for, if I'm trying to substitute here, I can write this. If I'm writing radius of helium, I can write that radius of helium is basically will be equal to mass. What I'll write 4 times mass of proton, and then I'm writing the charge again in terms of protons. So I write it as 2qp. Okay, and then if I'm writing it for proton, so I write it as mass of proton upon mass charge on proton. If I'm writing radius of electron, I'll write it as mass of, in terms of electron only will write. So you can write it in terms of proton. So mass of proton, if I'm writing substituting mass of electron in terms of proton, it will be 1837 times of mass of proton is equal to this much. I'm substituting mass of electron. So mass of electron is 1 by 1837 of mass of proton upon charges will stay same. So this is something that if you see, and if I'm talking about this thing, so what it happens is somewhere you get a value here in terms of, because if you take root over, if you cancel this value from here, if I want to write, I can write this as what, that R of helium root under, so root under 4 will become 2, so 2 upon root under mp upon 2 qp. This and this gets cancelled. So I have root over mp upon qp. Rp is also the same. So what I can write, that radius of helium will be equal to radius of proton, and it will be greater than radius of electron. I hope the question is clear. All the data on the related formula I have written. This is what is the first thing, second thing, third thing. Okay, and this is the fourth equation. Using this, if I substitute this thing, so here, because if this is constant and b is constant, if both is constant, so what I can say, I get radius is proportional directly to root over m and inversely proportional to q. I write separately values for this thing in terms of rp only, everything, so that we can compare it. Because charge on qp and q is same, so I can write it like this. If I write, I simplify this, I get it as root over mp upon qp, which is equal to rp. And re is obviously less because the mass of proton is comparatively very high related to electron. Even though the charge is same, so they're directly proportional to this thing. So that's why we write that mass of proton is quite high compared to mass of electron. I hope it is clear. Good questions. Okay, we'll move to the further thing. Move to the further question. Mass ratio and charge ratio. You can use the just previous concept and you can do it. Using the same previous concept, you can solve this. Okay, you try to solve this. I'll just give you the answer. It's the same concept. Okay, this is what is the answer. I'll move to the next question. Okay, solve this. In an experiment, electrons are accelerated from rest by applying voltage standard volt. Okay, solve this. Okay, see here. Again, this is radius of the path they are telling you to find out. We are using it from that time. Radius is equal to mv by qb. Now, because they have given you the voltage, it is accelerated in experiment, electrons are accelerated. So I can write mv as equal to 2 mk, where k is kinetic energy, or we write it as k kinetic energy upon qv. Now, kinetic energy for an electron accelerated with potential V is given by E into V. So I can substitute in place of kinetic energy 2m into this is charge on electron into the voltage. This is not velocity, this is voltage. Because the electron kinetic energy for an electron accelerated, any charge accelerated with an V potential, we write it as E times V. If it is helium, I'll write it as 2e times v. Proton, for again, it is e into v upon q by b, qb. Okay. So now again, same thing. I can write q also because it's electron. So we can write q also as what? E. So q can also be written as. Or I can write this formula in this fashion as well. I'll put that t, I'll just divide the terms. So I can write it as 2m e into v upon b. Okay, this all is under root. Okay, so I can substitute it in here. 2 into mass of the electron is 9.1 into 10 raised to minus 31 kg into 500 volts given upon E is how much? E is 1.6 into 10 raised to minus 19. This total under root, and this being divided by, this value is being divided by B, which is 100 millitesla. So I'll convert milli into Tesla, so 10 raised to minus 3 Tesla basically. Basically, if still simplify, I can write it as 1.6. I can write it as 9.1. 2 into 5 will become another 1000. So 1000 10 raised to minus 19 and 1000 will become how much? 22. So 10 raised to minus 10. If I'm writing it as like this, if I write it as like 0.16, it will become 10 raised to 9. I'll try to keep the power even. Division will be easier, like taking under root will be easier. If I'm taking it in even, odd is again, it will give you decimals. So this is there. Approximately, I'll assume 9.1 is 3 and 0.16. I'll take off this 100 from here. It is, so I'll take it as 0.16. So here I'll get 100 again. So take out this and I'll get 100 over here. So 10 raised to minus 2, basically 0.1. So I can write this as 9. I'm assuming it to be 9. So 3 into 4, 10 raised to minus 4, which will give you no option. So 3 into 4 points, and so something around 7. So this is what will be the answer. 10 raised to minus 4. You see, concepts, same thing, same, most of them is same. This and all is the formulas. People, they're just trying to interrelate two formulas. Okay, next. Try this. Same type, same question. Electron will be least and Rp and Re will be equal. R alpha, electron will be least and Rp and R alpha. This was just now, which we did previously. Same type of question being repeated. All this. So something different. Okay, see here. The charge given on this, the charge is basically equal to 2 into 10 raised to minus 6 coulomb. And they have given you the magnetic field, that is B, which is acting along y direction. So I can write it as 2j Tesla. Velocity is given as 2y vector plus 3j vector into 10 raised to 6 ms minus 1. So using the formula for force, magnetic force is equal to QVB. Okay, so I'll do this. Q magnet vector is QV vector times V vector. If we are trying to find out this is 2 into 10 raised to minus 6. V vector is 2I plus 3j. Okay, into 10 raised to minus 6 into B is equal to 2j. Now you know that this, if they're similar, it is equal to 0. So I can only get a product as, and product of I to j will give me k. So I can write it as, and this 10 raised to minus 6 will cancel this 10 raised to plus 6. So I'll basically get it as 2 into 4k vector, which will give me 8k. Okay, so I can write it as 8 Newton. They're asking me direction, so k basically represents z direction. So 8 Newton in z direction. You see, because it's again circular path, so the question stays again same, mv square r, it is equal to q vp sine theta. Sine theta will become 1 because we have perpendicular magnetic field. So vv gets cancelled. I get from here mv is equal to q br, and from here I can write velocity is equal to, now I am writing velocity is equal to, because they're asking me time period. I know that time period for a circular motion, it will be distance upon velocity. So distance upon velocity. So distance is this. Distance is this 2 pi r upon v. So v is q b r into m. So m goes up So I get it as 2 pi m upon qb. So 2 pi m upon 2 pi m upon q. Okay. Next. Yeah. Okay, we'll see the solution. If they're asking at the center formula is mu naught Ni. If they're asking at the end of the solenoid, we talk it as mu naught Ni by 2. So if I'm writing it for the first case, if I want to write, say, B1, so B1 will be written as mu naught N1 I1. So mu naught is mu naught. N1 is 200. Right, N1 is 200. It is given. Current is I. B is given to you as 6.28 into 10 raised to minus 2. And I have B2, which is again mu naught. Number of turns here is 100. 100 per 100. I becomes psi by 3. Okay. So you can divide it, obviously, that option is there, but you have another option also. You can multiply it by 2. So if you're multiplying this equation by 2, it will become on this side again, this will also multiply it as 2. And this side also you multiply as 2. So this particular term will be equal to B1. Right. So basically I'll get it as this, basically I'll get it as 6.28 into 10 raised to minus 2 upon 6, which gives me something around 1.02. So 1.02 is not there. Okay, 1.05 10 raised to minus 2 Weber per meter square. So this is the formula basically. At the end, when we write a magnetic field of solenoid at the center is mu naught Ni. And when I'm talking about at the end, this is at the center. And this is at the end when we write it as it is mu naught Ni upon 2. Next. Okay, merit merit of galvanometer is the formula to find out merit of galvanometer. Galvanometer is given as I upon theta deflection, that is I is given as 6 into 10 to minus 3 ampere, theta is 2 degree. To solve this, it will become 3 into 10 to minus 3 ampere per division. So 3 into 10 to minus 3. Only thing is you should know the formula that merit of the galvanometer is equal to current over deflection. This is current over deflection. Current over deflection. Okay. Next. Fine. Okay. So we'll try to solve this. Now, what is galvanometer? The formula for this is torque in galvanometer is given as Bina sine theta. It's like Bina, Bina sine theta. Sine theta they have given. The galvanometer coil is 500 turns. Each turn has an average area of this much. If torque is 1.5 Newton meters, required to keep the coil parallel to the magnetic field. We're trying to keep that parallel to the magnetic field. What we are torque? If torque is trying to keep it parallel to the magnetic field, when a current of this is strength. Okay, so if it is parallel to the magnetic field, that means it will be perpendicular to the. It is parallel to the magnetic field. That means it will be parallel to the perpendicular to the coil. I can write torque is equal to Bina sine 90 degrees 1. I need to find out what? I need to find out strength of the field. So I need to find out B. B is given as tau INA. Tau was given 1.5 SI unit, so no changes. Current is 0.5, so no changes SI unit. Number of turn is 500, it's a number. And then I have area, which is 3 into 10 to minus 4 meter square. Option is not there, so it's out. This goes up 5 times 3 times 3. So I have basically 1 by 5. This goes up, becomes 1005, cancel 0. This is basically 5 times 20. So answer here will be equal to 20 Tesla. The formula for torque is this: BINA sine theta. This is torque formula. Torque formula. Moving to next question. Okay, next question. So next question is again related to your galvanometer deflections. Okay. So how to find out resistance in galvanometer? Resistance in galvanometer is used for, it's found out using, it's equal to basically current sensitivity upon voltage sensitivity So current sensitivity over voltage. So it is basically 10 upon voltage sensitivity to 5 ohm. Now to find out Ig value, Ig will be calculated using V, that is moving coil galvanometer 150 upon 10 per division. So 10. So it's basically will be given in, this will be calculated in milliampere. So 15 milliampere. Now to find out the resistance, formula will become R is equal to V. Okay, R is equal to basically 150. So we are finding out the voltage. For one division is dismissed, so 15 divisions, 150 upon current. Current is 10 raised to minus 3. Gives me answer something minus 5. Okay, finding out minusing this. Okay, so basically V by Ig, it's V by Ig. The formula is V by Ig minus G. V by Ig minus G. Voltage upon the current in galvanometer minus the resistance of galvanometer. It will give you answer something around 995. Very common question. 995. Basically, you'll get it as 10,000. 10,000 minus this is, you can see from here. This gets cancelled. This goes up 10,000 minus 5. Okay. Okay, this is basic question, and I'm talking about magnetic effect of current. We'll do a few questions related to AC. Okay. This first question, alternating current. First question is this. We can start off with something. See. We can start from here. That's all this. Okay, we'll try to solve. E is equal to E naught sine omega t. This is the AC equation when we have. So whenever we try to write it, to find out the power formula is given as E RMS, E root mean square into I RMS, I that is current RMS, it times cos phi. Now what is given here is E equation is given as in the form of E naught sine omega t. I is given as I naught sine omega t minus pi by 2. If I'm trying to compare this thing, you can see the phase difference, that is phi, is coming off pi by 2, and pi by 2 is the phase difference. So if you substitute it here, cos pi by 2, irrespective of what is the value of ERMS and what is the value of RMS, cos pi by 2 is equal to 0, which makes this whole term equals to 0. So this is what is the option. Okay. Next. Okay, you have to find out quality factor. Quality factor is represented by Q. The formula for quality factor is 1 by R root under L over C. So R is equal to 100 ohm. L is equal to 80 millihenry. So we'll convert it into this 10 raised to minus 3 SI unit, and this is 2 into 10 raised to minus 6 farad. So if this will be basically 40, and this goes off 10 raised to minus 9 plus 9 becomes 10 raised to 3, 40 comes out 100, gets cancelled. So basically I'm getting it as answer will be equal to 2. Answer will be equal to 2. So this formulas, if you know the answer. If the formula is so you don't know, then you don't know the answers. It goes like that. Try this. What is given here is R is given Q, which is equal to 100 ohm. Then XL is given Q, so XL is given, it will be L omega. L is given as 0.1803 Henry. Into omega, we can write it as 2 pi F. So 2 pi F is equal to 750 Hertz. To solve this will be something around 850 ohm. And when I'm trying to find out XC from here, XC will be equal to 1 by omega C, where again same thing 2 pi F. So I write it as 2 pi into, I have capacitance as 10 raised to, so I can write capacitance as 10 raised to minus 6, 2 pi F will be 50 and C is, so I can write this. This will give me the answer in the terms of this. This will be equal to 21.23. Okay. Now, if I'm finding out impedance formula is given as R square plus XL minus XC whole square. So R square is nothing but it is equal to 100 square. 100 square plus XL is 850 minus 21.23 whole square. Okay, solving this, we get the value approximately as 134.77, which will be equal to 135. Again, the value stays same, ohm only, because the resistance. You have to find out the heating effect is given to you. So we have to find out the current. So we have I square RMS RT over here. So if I'm trying to find out the value here, so I can write this as what? V RMS upon Z whole square into R into T. Okay, so this is basically equals to MS delta T. Okay, if you solve this thing after substituting everything, you get the value approximately equal to 348 seconds time. What is given here? Reactance is given to you, that is 100 ohm. I can write that as 100 ohm. The frequency is given to you. Frequency I write which is given to us 1000 hertz, and then the voltage leads the current by 45 degrees Celsius. So phase angle is basically given as phase angle is 45 degree. If I want to calculate tan, I can write that tan phi is equal to XL upon R. So because it is tan 45, tan 45 is nothing but 1. So I can write that XL is equal to R. So using this, what I can write that reactance in case of purely inductance, I write Z is equal to XL whole square plus R square. So because both are same, I can write it as 100 square is equal to R square plus R square, because both are same using this equation. So I basically get 2R square equal to 100 square. Basically R will become 50 root 2. If R is equal to 50 root 2, same equal to XL. So I can write that XL is basically, now I can write XL is equal to omega L. Omega L value is equal to 50 root over 2. Now I from here, if I want to calculate self inductance, that is L, so L can be written as 50 root 2 over omega. Omega can be written as 2 pi f. So 50 root 2, 2 pi into f is basically equal to 1000. This 1000, so this gets cancelled. 5 times 20, so it's basically root over 2 over 40. So if I'm trying to solve this, it will be basically equal to 1.1 into 10 raised to minus 2 Henry. 1.1 into 10 raised to minus 2 Henry. Okay. Moving to the next one. Okay, so according to the question, omega is omega t. So omega is basically given as 100. So 100 radian per second. I can write that if it is tan phi, the phase difference is also given. So tan phi is basically XC by R for capacitive circuit where the L is absent. So tan 45 pi by 4 is basically tan 45. So I can write from here that XC is basically equal to R, or I can write here as what R value is also given to you as 1 ohm. So I can write that XC, that is omega CR. I can write from here, or you can simplify this as well. So to give you more clarity, what is there is I can write omega CS XC as omega C equal to R. So I can write from here that omega CR is equal to 1. If omega c is equal, R is equal to 1, if I'm taking a value, So if I'm taking from this CI, I'm taking omega. So 10 into 10, 10 raised to minus 6 into 10 raised to 3. Okay. I took all the value. I took omega value. Omega value is 100. Then I'm taking the value for, I'm just taking value for this thing. If I'm taking this as 1 microfarad, so I write it as 10 raised to minus 6, kilo is 10 raised to 3. This satisfies basically the equation, because this all will be basically, it will start giving you the value nearer to 10 raised to 3. Right. Okay, so this is what will be our value, which will be, so this is what will be the equation. Next one. So next one, if I'm writing it, we know that from here we can write this is basically V naught and this is I naught. So V naught is equal to 100 and I naught is basically equal to 20. Then sine omega t. So from here, if I want to write, we can substitute the values here. Okay, so if I'm trying to write, I can write velocity average is equal to, sorry, P average is equal to V RMS, voltage RMS into I RMS cos phi, which is phase difference. So I can write V RMS as V naught over root 2, peak value, that is V naught, I naught is peak value of current over root 2. Cos phi is basically given to you as 45 degree. The phase difference is 45 degree. So cos 45 degree. V naught value is 100. So 100 root over 2. So this is basically 2. And I naught is equal to how much? So I naught is 20. And cos 45 is equal to how much? Is equal to 1 by root 2. So this is 10. So this is 1000. So 1000 upon root 2. 1000 upon root 2. If I'm trying to find out wattless current formula is IRMS, I virtual you say, or IRMS you say, by into sine phi. IRMS is basically I naught root 2. I naught is nothing but 20 root 2 into sine phi. Sine 45 is again 1 root 2. So this is basically 20 over 2. It is 10. So this is 10 ampere and this is power, so watt. So this is what is option. On to the next one. So next question is, we need to find out the frequency. Frequency formula is given as 1 pi 2 pi root under L into C, which is equal to 1 by 2 pi LC. So L formula is, L value is given as 224 times, now C, so 2 into 10 raised to minus 6. If you solve this, it gives you a value something around 23 hertz. So this. Okay, formula again. Formula, if you know the answer. If you don't know the formula, substitution part, it will be very difficult. Okay, so you have in an LCR circuit, we have R is equal to 200 ohms. So now what is that? We have a capacitance, which is, if when only the capacitance is removed, phase difference, how we'll find out? Only capacitance is removed, that time we write the phase difference tan phi is equal to XL upon R. So I can XL R, so I can write that omega L is equal to R tan phi, which is equal to 200. Tan phi, tan 30 degrees, basically 1 by root 3, which is equal to 200 root upon 3. Okay, when only inductor will be removed, that time we'll write what? This will be when only the so when only inductor is removed, that time we write tan phi is equal to 1 by omega CR, because it will be XC by R. XC is equal to 1 by omega CR. So from here I'll get basically what I'll get is 1 by omega C value, will get it as 200 by root 3. 200 by root 3. If I'm trying to find out impedance of the circuit, Z is equal to R square plus 1 by omega C square, 1 by omega C minus omega L whole square, because it will be basically XC minus XL whole square. If I substitute this, the values we have is 200 square plus 200 root over 3 whole square. This basically this and this cancel each other, so this is nothing, this is 200, so it will come out as 200 ohm. So power value will be equal to Vrms IRMS cos phi IRMS. So Vrms formula again we can write it as IRMS, also can be written in the terms of Vrms as what? I can write this as Vrms upon Z. Cos phi is also can be written as R by Z in terms of when I'm talking about LCR situation. So V square RMS into R upon Z square, impedance square, to find out that I have all this value. So 220 square into R will be equal to 200. So cube upon Z is equal to 200. So 200 square. So 200 and 200 gets cancelled. 220 is a 440. Okay, so it will be something around. This will be 22 into 22 into 100. 2 into 100. So 100 gets cancelled. 11. So 11. So basically, it will be equal to 242 watt. 242 watt. Next. Fine. So next question, it's an series resonant LCR circuit. If it's a resonating circuit, in case of resonating circuit, we write XL is equal to XC. You have R value, R1, R is 100 volt, the voltage, R is this much, C is this much, resonant frequency is this much. What will be the voltage across L? So we have to find out voltage across L. So I can use first formula to find out I is equal to V by R, where so I have V value given as I have V as 100 and R is 1 kilo ohm, so it is 1000. Basically current becomes 0.1 ampere. Also in resonating situation, XL is equal to XC, so I can write basically that XL, which is equal to omega L, is equal to 1 by omega C. So I have the values, omega is there, so omega is equal to 200 into then I have C value, C is 2 into 10 raised to minus 6. I have all the values here. Okay, so we can substitute that this thing here, and it basically gives me something around equals to 2500. Now if I want to find out voltage, so voltage basically is be equal to what? Current into XL. So this is XL value. So XL will be basically current is 0 ampere into XL. This is, so this will be 2500. So basically it will be equal to 250 volts. 250. Right. The self-inductance of a motor is this much in order to impart maximum power. To impart maximum power, this is the condition of resonance where XL will be equal to XC. Now we can write what from here is, we can write this as omega L is equal to 1 by omega C. So I can write C value is equal to 1 by omega square L. Okay, so omega square L. So omega square I can write it as, we have a self-inductance value, L is there, frequency is there. Okay, so I can write it as 2 pi F whole square, 2 pi F whole square into L. I have the value, so 1, 2 pi, frequency is equal to 50 hertz, so 50 whole square into L is equal to 10 Henry. 10 Henry. So basically it will become how much? It will be something around, the value comes as 0.1 to 10 raised to minus 5 Faraday, or you can write it as 1 micro. Right, so 1 microfarad. Okay. Right. So next question we have is, in a transformer, number of turns in primary coil. So number of turn primary coil is NP, and in the secondary coil this is NS. If the current in the primary coil, so IP is given to you. So we know that the formula for this is what? Ratio for a transformer. We have formula as what? IS, I current in secondary upon current in primary, will be equal to number of turn in primary upon number of turn in secondary. So IS, I have to find out the current IS. So IS will be basically NP by NS times IP. So NP is basically number of primary coil is 140 upon 280 times IP is nothing but 4. So 1 by 2, 2. So 2 ampere. 2 ampere. This is the formula for it. Okay. Right. Okay, so this is basically an idea of magnetism chapter which we are covering here. Okay. Further, we'll have a session. Next session will be there on modern physics. Okay, we'll stop the class here. Thank you for joining. Bye.